And now I'd like to introduce our presenter, Joe Marchese.
Thanks, Bob. I appreciate that introduction. Let me know when I could show my screen. I guess now's the time.
Yeah, I think your screen is up.
Okay. Can you see my screen okay?
Yes.
Okay, perfect. Well, welcome everybody to tonight's webinar. Before we get started, I just want to remind everybody, hopefully everybody's remaining safe, and if they have to go out and service equipment during these times, they protect themselves as much as they can. Tonight's webinar is, as Bob mentioned, is on some tricks and tips that I've accumulated over the years servicing systems. And basically these tips and tricks that I will show you tonight really come from me being an RSES member. One of the wonderful things about membership in this organization is you get to meet technicians, and in my case, I was able to meet different technicians throughout the whole country at different times. And during those travels and during those times of having these interactions with all different technicians, I was able to pick up tricks and tips, and they showed me different ways of servicing systems, or gave me some suggestions on how to better service equipment, and I thought it would be a really good idea to collect these tips and tricks and kind of share them with everybody at one time. So that's what this webinar is basically all about. It's just little bits of information. It's not focused on any one topic or any one area. It's just things that basically RSES members have shared with me over the last 30 years. Some of the stuff you guys probably will already know. Some of the stuff is not new. It's not rocket science, but some of it may be, that's, you know what, this is interesting. That is a good way of servicing that system, or looking at the system in a different approach. So that's where we're going to focus on tonight, and I hope you enjoy it. So let's get started. And the first one we're going to start off with is basic, right? So when you're servicing a piece of equipment, you're going to a location, whether it's a residential system or a commercial system, really doesn't matter. I think the best first step for any technician trying to get into troubleshooting the problem is to have a discussion with the customer about what the problem is, or get some background history about the equipment. Maybe when's the last time it was serviced, what parts have been changed over the last couple of years, had it been working well up until the failure, or had it been struggling up until the time of failure. All these little bits of information can be quite useful. Now, you don't have to go crazy with it. You don't have to have a 5-hour discussion with the customer, just a brief discussion, and get some good information about the system that you're going to tackle, so it might make your job a little easier. Once you have that information, then I think the next step for you guys is to don't pre-diagnose the system. And I think a lot of us do that. We diagnose the system by prior jobs or stuff that's been happening in the last 6 months. And though there's a lot of stuff that does repeat, there's a lot of issues that are not necessarily going to, a lot of problems that are not necessarily the same. So what I would recommend is, when you go on a new service call, keep it new and don't pre-diagnose it. And after you speak to the customer, do a walkthrough, no tools, good flashlight, and just look at the equipment and kind of get a sense of what you're going to be tackling. More important, if it's the first time that you've been on the job, if it's a repeat customer and you know the system, this becomes less crucial. But if it's the first time that you've been on the job, definitely a walkthrough, looking around, makes a ton of sense. And even if it's a pre-existing customer and you've been there before, I'd still recommend doing a quick run through of the system without getting your gauges out, without getting your tools out. Just look. I always do that. I never walk into a job site with my tools in hand. I always walk in with a flashlight, speak to the customer, and just look at what I have to fix. So some of the things you want to look at, obviously, is what's running, what type of refrigerant. Today, that is very important. There's so many different refrigerants in the industry that you could potentially come across. You got to know the type of refrigerant you're working on. It's going to make all the difference in the world when you start to get into the system. And then check your coils, check your heat exchangers, check your condenser coil, check your evaporator coil, you know, see if they're dirty, iced over, if the fans are running, you know, just the basics. Definitely walking around and looking at what you're going to service is definitely a good tip and something to do all the time. So another tip of the trade, and a lot of experienced guys that you work with, you know, they got this down pat. Patience is so instrumental when it comes to servicing systems, and it's the experienced guys that have learned over time. Take your time. You'll fix the problem. You don't have to jump to it. You don't have to figure it out in 5 seconds or 5 minutes. And you might think of those old timers of being really slow and lazy, not lazy, wrong word, but really slow at their job. They're not slow. They're just being very patient. They've made the mistakes that we've all made. They've inaccurately diagnosed systems by rushing to an early conclusion. So they've learned patience over the years. And I'll be the first one to experience that. When I first started out in this trade many years ago, working for my dad, I wanted to be the guy that figured it out in 5 minutes. And I can't tell you how many times I've misdiagnosed something by jumping to an early conclusion. Now I've learned, take my time. I'll get it. I'm looking at everything. Patience, so critical. And experience teaches you that, you know, to learn the rule of patience. So another tip I want to share with you guys is when you come across difficult systems to repair, and honestly, not every system you come across is going to be hard to repair. Actually, most problems are pretty easy to diagnose, but you will come across some difficult issues and some jobs that, you know, the real cause or the root cause is eluding you. So one very helpful tip, and a lot of manufacturers support this, is just what's called read and record. And there's different forms out there. There's different templates out there. This one I'm showing you on the screen now is just something I put together for myself, but I was at a Copeland training class recently, and they had another one that they were handing out that was fantastic. So these read and record sheets make you think about the system. And there's two major advantages to doing this read and record. One, just the process of alone of going through the measurements makes you think about the system to the point where you will probably figure out the problem by the time you've recorded everything, because you're going through it. It's making you not skip steps. And when you skip a step in the troubleshooting process, some of the times you overlook the obvious. So this prevents you from overlooking some of the things you should be looking at. And then another crucial point of this read and record is you have the information on paper in front of you. So now when you go to seek advice or get help from whoever, the manufacturer, a colleague, a wholesaler, whoever you're calling to get some help, you have solid information you can share with them. And you don't have to say the superheat is good, or the subcooling is good, or the temperature drop is good. Guys trying to help other technicians don't need good, they need actual numbers, right? They need, what's the superheat value? What's the subcooling value? What's the temperature drop? What is your suction pressure? What is your discharge pressure? Real numbers. And then with those real numbers, they can really get down and help you. So this makes you do that. And a very good good tip or good trick to use when you're running into a difficult problem. Now, it's not definitely something you have to do in every service call, right? It's not a you do it every time. It's really for those systems where you really have to analyze it, very detail oriented. So wherever you get yours, if you make your own up or you get some from a manufacturer, definitely good to keep on your service truck as a means of recording some information. I'm also a big believer in this technique or this tip, and that is recording in a logbook if you can what was done to the system. You know, you're gonna speak to your customer, and the customers are gonna give you some prior history, but honestly, they don't know the technical side of everything. Their information is still good, and you still want to speak to the customer and find out that information from them. But having a prior technician's report in front of you is fantastic. So if you can, if you're servicing systems on a regular basis and you and your company, that's your customer, definitely very beneficial to have a logbook. Maybe not a logbook for each equipment, maybe a logbook for the mechanical room. If there's a mechanical room that has multiple systems, have one logbook for the whole mechanical room. And then in lieu of this logbook, I think a really good technique on those single systems where you have just one and done, or just a small restaurant kind of a application, you know, just take a Sharpie, and a lot of guys do this already, and I get delighted when I go on a job and I see this information there, where guys have in a black magic mark or Sharpie or writing down what they've done previously. You know, they obviously put the refrigerant type. If they change the refrigerant type, they're marking that down. If they added refrigerant and fixed a leak, they're writing that down. If they changed the component, they're writing it down. Unbelievably valuable information. So it'd be nice if you did that for your customer, so the next guy on the job has some prior history of what was done. You can't believe how helpful that can be when you're looking at a system. So either developing a logbook or just a Sharpie or a note or whatever you can do to kind of record some information on that system when you leave, definitely a good tip and a good practice to perform for everybody. Today, with all the information that is not information, today with all the technology that's advancing in our trade, you can't know everything as soon as you walk up to a piece of equipment, especially when you're dealing with electronic boards, controllers or control boards or PC-based systems. Anytime you get into the electronic world, you can't look at that board and know exactly how that board is supposed to function. Back in the day when you were dealing with relays and contactors and mechanical switches, you can trace it out. You can kind of get a sense easily of how everything was designed to put together. But with electronic boards, those days are gone. You really need to reference the manufacturer's literature. So I'm a big believer on creating a library for systems that you normally service. In the electronic form, you can gather a whole lot of information on a tablet, on your phone, on different electronic devices, and I would recommend that you just start stockpiling information. Every time you go on a piece of equipment and you have to find the manual, keep an electronic version of it. Now, if you're not an electronic guy and you're still a paper guy, that's fine too. Take that paper manual, get yourself a binder, get yourself something, and stockpile the paper forms, the paper manuals in your truck. Unbelievable how nice it comes when you need to find a piece of information and you can go to a manual and look it up. Definitely very, very helpful, especially if you deal with ice machines. If those guys out there that are working on ice machines, the manuals and the troubleshooting guidelines that manufacturers give you are tremendously helpful when it comes to ice machines, and just in general, any system where the manufacturer has put the information in a manual form definitely is a useful tool to have when you go to service systems. So if you don't already do it, collect information, start now and start stockpiling. It will definitely benefit you down the road. Okay, so here's a recommendation, a tip when it comes to troubleshooting a system. And one of the things you want to look at is the whole picture when you're analyzing a problem on a refrigeration or air conditioning system. I kind of say, don't be a one gauge technician. You don't want to be that guy that just looks at the suction pressure, just looks at discharge pressure, and makes a determination what the problem is based on a one gauge reading. You gotta look at the whole picture, especially when you're looking at an issue where your low side pressure is lower than normal. That could be the result of low on refrigerant, but it also could be an airflow issue too, where you're not moving enough heat across your evaporator and your suction pressure is dropping, and it's adding refrigerant definitely not the fix. Fixing the airflow issue, or fixing why you're not pushing enough air across that coil is the issue. Adding refrigerant creates an issue at this point. Now, if you measured your high side pressure, that may help you identify those issues. But looking at everything helps you identify the problem. So be that guy that really looks at more than one piece of the puzzle, looks at low side, high side, airflow. You know, those air conditioning guys out there that are working on air conditioning systems, looking at your airflow, very critical. If you don't have the right amount of air moving across your coil, your pressures are going to be off, your temperatures are going to be off. You can add and remove refrigerant all day long and you're not going to get it right. So that's why you want to look at everything. It's part of what we do, right? We are investigating problems. We're a little bit of a detective, so we don't look at one thing, we look at everything. So I recommend looking at the whole picture and thinking about the whole picture when you're looking at problems. Data loggers could be useful. Temperature loggers, they do make a pressure logger out there, but temperature loggers can be beneficial on certain systems when it comes to identifying problems that are not apparent when you're there. Give you a great example of this. Recently happened to me on a supermarket rack system. One of the compressors kept going off on an oil pressure control, oil failure, repetitively. Went there, go to the job, reset it, works great. Next day, maybe 2 days later, it goes off on oil again. Go there, check everything. Oil pressure is good when I get there. It was about 30 pounds over the suction pressure. So it seems good. The oil level in the sight glass was good. It was fluctuating between 1/4 and 1/2. So everything was good, looked decent, right? I waited around, not a problem. So my thinking was, yeah, maybe it's the pressure control. Maybe the pressure control is the issue. So let me go ahead and change the pressure control. And then I stopped and said, well, you know what? I'm not 100% sure it's the pressure control. Let me put a logger on, and I did. I logged the oil pressure over time, and what I found was that the oil pressure was gradually going down. It wasn't where the pressure was good and then it shut off. The oil pressure actually did start to go down lower and lower and lower, and then finally it tripped off on the pressure switch, and the pressure switch was doing its job. It was protecting the compressor. Long story short, it ended up being the whole rack needed more oil. So I had to add a little bit of more oil to the rack, and that solved the issue. The data logger prevented me from changing out a pretty expensive pressure control that didn't need it. So that's just one example. There's other examples you can probably come up with, but logging temperatures and pressures over time can help you to identify an issue on one of those tricky scenarios where the problem is not there when you're looking at the issue. So I would recommend thinking about getting some data loggers. There's temperature-based ones out there, not a lot of whole pressure-based ones, but you could probably find something. Here's a trick or a tip that a member had shared with me once. On a hermetic system, if you want to get an oil sample out, pretty difficult to do, but with this little setup, you could take an oil sample out. And basically what you're doing here is you're putting a inverted T in the suction line, pretty close to the compressor, but maybe not directly at the compressor, but in the suction line. And that inverted T with a Schrader valve and a sight glass, as the system is running, the oil will, as it's flowing back to the compressor. Oil will collect in the sight glass, and when you see the sight glass full of oil, you can quick disconnect it with because it has a Schrader valve on it. Now, this does take a little ahead of the curve thinking. If you're gonna know you're gonna have to do this type of work, you do have to put this inverted T ahead of the job when you're either replacing the compressor or doing a major repair. So you just can't add it easily. It does require opening up the system. But if you're opening up the system and you know you're thinking you need a oil sample eventually, this little trick of getting an oil sample can help. Like on a compressor burnout, you're replacing a hermetic compressor, it's a burnout, and you want to do an oil test instead of a refrigerant test. If that's your choice, and you want to get an oil sample, this could be a benefit to you. It is a trick of getting oil out of a hermetic system without a oil port. So if you ever working on a soldered joint, an elbow close to a wall, that picture there shows it a soldered elbow close to a wall, not a refrigerant line. This little tip here, really not for refrigerant lines, but more for like condensate lines or a water line, anything that has a soldered elbow, and you have to replace the elbow. Well, what you can do is you could take a hacksaw, cut down the middle of the elbow, right down the center, and then you can unsolder this joint, clean it up, put a new elbow in, resolder it, and there you go, you're all done. And that would eliminate having to put a coupling here and a coupling there. You can do it all in one joint.